Hey, Bogdan Rzewski here, where we make algebra easy just for you. So welcome to the next video. In this video, we'll be going over synthetic division of polynomials, shortcut that you need to know. What is important here to learn the process, and then in the conclusion, we'll share with you if this is the best method for you when dividing polynomial, and if that method really works all the time 100%. So let's go. In this beautiful video, I have this nice example where we will be dividing the following polynomial. So let me grab my magic pen. Okay, so this is the example right here. So this is the cubic polynomial with coefficient 6. The degree is 3, x cubed divided 6x cubed minus 15x squared minus 2x plus 5. So this is the dividend, and this is the divisor, 2x minus 5. And when we divide, we will show you that the result is 3x squared minus 1 using synthetic division strategy. So the first thing that you must know is always the following. Please identify if your polynomial that you're going to divide is showing terms in descending order. So from highest to the lowest. So that's a number one observation. In case there is a term that is missing. So I have cubic, then I go down to quadratic, linear, and constant. So I'm good. If there was a missing, let's say quadratic was not visible, then you have to insert 0 place value holder so that you have beautiful setup where every term is accounted for. Very important. Synthetic division or long division, the same idea. Now, the divisor is given in the form 2x minus 5. So the key here is, when using synthetic division, to factor the leading coefficient from the divisor. So take out 2, and then you have x minus 5 over 2. So you would divide by x minus 5 over 2 first, and then you divide it by 2. That's the strategy. You divide by binomial x minus 5 over 2, and because of the product 2 times that binomial, in order to completely divide it, you would have to divide by 2 in the end. So let's dive into it. So what you do is the following. You create a little table like so, little chart, and then you organize it by bringing it into the chart those leading coefficients. So 6, negative 15, negative 2, and positive 5. So this is where you start. You start creating this first line here. Outside of that box, you use that restricted value. That would be restricted value for the denominator, right? 2x minus 5. So x minus 5 over 2. Positive 5 over 2 is the restricted value. So you keep that outside. And then the first step starts with the following. You bring the leading coefficient down to the outside of the box, which is 6, and you start multiplying 5 over 2 times 6, which is showing right here. And then the result of that multiplication is inserted right inside under the second term. And then you add. So 5 over 2 times 6 is positive 15, and when added, the answer is 0. And you put that result right next to that term 6. So the first, then the next one. And then you will create the following terms using that spot, that particular line under the chart. So you proceed with the same steps. You multiply 5 over 2 by that second number down, which is 0. You insert the result into that second line, and you add. So negative 2 plus 0, obviously it's negative 2. And then you continue, negative 2 times 5 over 2. You put the answer right here. So with a green print, the numbers are showing in green. Then you add, and we have the last term is equal to 0, which tells you that the remainder is 0. So it's nicely divided. So the answer would be, you divide 6x cubed by x. So that will be the coefficient, leading coefficient of the quadratic term, because you lower the degree, cubic by linear. So this would be 6x squared plus 0x minus 2, and there's no remainder. So this is how you get that right here, right? 6x squared plus 0x minus 2. And then remember, the coefficient 2 was the common factor taken out from the divisor, from the original divisor. So now, in order to complete fully the division, you would divide it further by 2, which is to multiply by 1 over 2 right here. So 1 over 2 times 6x squared plus 0x minus 2 gives you the result, 3x minus 1. Bingo! So this is the process of synthetic division. So to recap, you have to make sure that the dividend is in descending order. All place value holders are accounted for. The divisor, please note the divisor has to be factored so that the coefficient in front of x is taken outside, and you start dividing by x minus the number or x plus. And once you establish the restricted value, if it's positive 5 over 2, then you bring it outside the chart, you drop the first term, and you start the process. And then you divide it. In the end, the result must be divided by whatever the coefficient you factored out in the beginning. So that's the process, and this is the statement that shows the product. The remainder is 0 here, so the dividend is equivalent to the product of the divisor times the quotient. So hopefully that makes sense for now. Let's move down and sort of summarize what we did. So this screen shows you the division statement. It is a rational expression. And when you rewrite this in factored form for the denominator, then you can think of the following. We divided the numerator by this binomial to get 6x squared plus 0x minus 2. And now we would divide the new numerator by 2. So we're just showing you in steps. First divisor, then the second divisor, the common factor 2. So we get that 3x minus 1. So in general, in algebra, using the following approach, if you have your numerator in a form that it can be factored, and you look at the denominator that is in factored form, then you start matching the common factors, right? You know that from the past videos. So if I were to cut by C, this particular example, then I'm down to AB divided by B. Since B is another common factor, so you get the process, so the result of that is A. So we can say I can directly jump into the result, or I can show the step that leads to the same result. So this is what we did when dividing this particular example by 2 times x minus 5 over 2. So this is very important for you to understand that we don't stop until we divide it by the entire divisor. What is important also about synthetic division, that it doesn't work all the time. So when your divisor is a second degree term, you cannot use synthetic division. So you may say, why do I need to know it? In some programs, the math class that you take, they teach synthetic division, so I'm sharing that with you, but this is not 100% applicable to every single situation. So know your long division for sure. You must know how to divide polynomials. Synthetic division, if that makes sense to you, you would use it. Or perhaps this is just a requirement in your course that the teacher says you have to show synthetic division, then please know the strategy. But once you know the long division polynomial that was shared with you in another video, then you're good. So this is another tool, but it has limitations. So be aware of that. So hopefully that makes sense and you like the video. So share with your friends. And before you go away, immediately start going into practice questions. Why is that important? Because practice questions solidifies your learning. So do those questions, post any comments down below, and we'll see you in the next video. Bye for now.